In the beginning, there was darkness, not just the absence of light, but the fertile canvas upon which light would one day be born. Across that primeval void, atoms waited like unwritten words in a cosmic storybook, yearning for the spark that would give them meaning. And then, somewhere in the infinite hush, gravity whispered to hydrogen and stars ignited. Each one was a living lantern forged in the vacuum, casting illumination across the eternal night. Billions of years later, on a small blue world circling an average star, a species would raise its eyes, attempting to capture that stellar radiance in its own fragile hands. We would build our own small light's tiny devices that banish the dark with the press of a thumb. Yet, even as we hold these small flames, we continue to search for a greater illumination, the kind that reveals the secrets of creation itself. One such secret arrived not from our sun, not even from our solar neighborhood, but from the deep interstellar gulf between the stars. A comet that did not belong to us. It came hurtling into our system, a messenger older than our planet, older than our sun, carrying within it a signature written in metal, the spectral fingerprint of nickel, an element gleaming at the heart of stars. When astronomers first glimpsed this visitor, its tail streaming like a brushstroke across the void, they sensed immediately that it was no ordinary wanderer. Its orbit was hyperbolic, its velocity defying our sun's gravitational pull. It had come from beyond, from the untamed regions of the galaxy where comets drift unbound to any star. We named it, studied it, and watched its brief passage with instruments tuned to the faintest whispers of reflected light. And in that light, buried amid the spectral lines, lay the unmistakable call of nickel. It was a soundless melody from the universe's own foundry, a hint that the building blocks of our world were forged not here, but in the furnaces of ancient, long-dead suns. Nickel isn't a trivial element. It's a child of cataclysm, birthed when massive stars explode, seeding the galaxy with heavy atoms. In those stellar death supernovae that can outshine entire galaxies, iron and nickel are fused in the crucible of collapse. They condense into the hearts of new worlds, into the veins of meteorites, into the coins in our pockets, and the very core of our planet. To find nickel in an interstellar comet is to touch the residue of a star's final breath. It tells us that the material of that wanderer was formed in the death throes of a star far away, long ago in a cosmic nursery we can scarcely imagine. Imagine holding a flashlight beneath the night sky, its beam piercing through the mist. The light scatters off dust, revealing contours otherwise unseen. That is what our telescopes did when they studied the interstellar comet. They shone invisible beams across space, illuminating the composition of something that had drifted through the dark for eons. The comet itself was like a relic adrift in a cosmic ocean, and we, curious beings made of stardust, reached out across that gulf with our instruments' tiny beacons of reason to read its message. The photons it reflected journeyed for millions of miles, entered our detectors, and translated themselves into numbers, graphs, and lines. From those patterns we heard a voice, "I was born of stars, I have traveled through ages, and now I pass through your home to remind you of where you came from." The nickel signature was subtle, faint as a ghost's breath, but it was there a testament to the unity of cosmic chemistry. We once believed comets were mere ice and dust, frozen time capsules of our solar system's beginnings, but this comet was a traveler from another sun, another history. Its nickel told us that the same laws, the same physics, the same elemental alchemy that shapes our world is written everywhere in the universe. It confirmed a profound truth: we are participants in a cosmic continuity, not exceptions to it. The atoms that compose our hands and eyes were born in the same thermonuclear fires that seeded this comet's metallic grains. For thousands of years, humanity has sought to understand the heavens. We mapped the stars, measured the planets, and imagined gods among the constellations. But only recently have we learned to listen to the subtle symphony of atoms. Each element hums its own note, and when we detect that tone from a distant star, a nebula, or a comet, we are hearing the music of creation. Nickel's line in the spectrum is one of those notes, a reminder that the cosmos is a single orchestra, playing variations on the same elemental theme. And through our science, we have learned to read that music, to understand that every light in the night sky is a lantern burning with the same kind of fire that powers our own hearts. Our small flashlights, trivial as they may seem, become a sacred metaphor in this context. They represent the unquenchable flame of curiosity that drives us to explore. Every telescope, every spacecraft, every data stream from a distant object is a beam of that same light. We shine it not only into physical darkness but into ignorance itself. We illuminate the unknown, and with every discovery, like the nickel in the interstellar comet, the boundaries of our understanding expand, pushing back the night. Consider how improbable it is that we can even detect such a thing. The comet itself was barely a few kilometers across, speeding through space at tens of kilometers per second, visible for only a fleeting moment. Yet from that brief encounter, from the faintest glimmer of its light, we extracted its chemical essence. That is the power of human ingenuity, a testament to the fire of the mind. We have become a species that decodes starlight, that can tell what an object is made of from the way it bends and scatters photons. To some, this might seem like magic, but it is not magic. It is science, the disciplined application of curiosity, guided by the light of reason. The discovery of nickel in that interstellar visitor is more than a fact in a scientific paper. It is a revelation about our place in the universe. Nickel is a storyteller. It speaks of fusion, of stellar life cycles, of death and rebirth. It links the heart of a star to the cold reaches of interstellar space, and from there to the instruments of human observation. In its presence we find proof that matter remembers. The atoms within us carry the memory of their origins, the heat of a star's furnace, the pressure of its core, the moment of its explosion. When that comet released its nickel signature, it wasn't just revealing its composition, it was whispering its biography. Our species, small and recent, stands on a planet that has seen only a fraction of cosmic time. Yet we have reached the point where we can comprehend such histories. The light from that comet entered our telescopes, but it also entered our consciousness. It told us that we too are made of the same fire, that our curiosity is an echo of the universe's own impulse to know itself. Perhaps that is the ultimate meaning of the flame, the fire that burns both in stars and in our minds. Nickel's presence in an interstellar comet also reshapes our understanding of planetary formation. If such heavy elements exist in icy bodies formed around other stars, it means that the recipe for planetary chemistry is universal. The same processes that created Earth's metallic core and the meteorites that seeded our world may be happening throughout the galaxy. Each comet, each planet, is an experiment in cosmic chemistry, and every discovery reveals that the universe is consistent, lawful, and shared. There is no privileged place, no singular origin, only endless cycles of birth, transformation, and return. As the comet receded into the distance, its brightness faded, its story written into our archives. Yet its legacy endures. In laboratories and observatories, scientists pore over data, refining models of interstellar chemistry. They replicate the comet's conditions, analyze isotopic ratios, and trace the fingerprints of nickel back to their stellar sources. And as they do, they participate in a lineage stretching back to the first humans who looked up and wondered what the lights above might be. Those ancient eyes saw only mystery. Ours see pattern and law, yet the wonder remains unchanged. The tools have evolved from fire-lit caves to photon-counting detectors, but the question is the same. Where did we come from? That simple, powerful question is the engine of all discovery. The next time you find yourself under a clear, dark sky, remember that you are looking at the past, at the ancient light of distant suns. And know that somewhere, drifting between them, are messengers carrying the same stardust that makes up you, me, and everything we have ever known. That knowledge is its own kind of light, one that no darkness can ever extinguish. Have you ever looked up at the night sky and wondered where we truly come from? The answer, whispered by the faint lines of nickel in a comet's spectrum, is more profound than you can imagine. We come from everywhere. Our atoms, the very building blocks of our bodies, are borrowed from the hearts of countless stars scattered across cosmic history. We are mosaics of stellar generations, our chemistry a beautiful, intricate patchwork quilt of cosmic events. The hydrogen in your blood, it was born in the Big Bang itself. The carbon and oxygen that make up your cells were forged in the cores of medium-sized stars. The iron and nickel in your bones, giving you strength, were blasted into existence during the spectacular death of massive stars' supernova. Every single breath you take is a conversation with the cosmos. Every heartbeat is a pulse in tune with the great, silent rhythm of space and time. And yet, for all this cosmic grandeur, we remain humble observers. We are fragile beings, holding our tiny lights against an infinite darkness. Our lights are small, yes, but they are deliberate. Each experiment, each question we ask, is a spark of defiance against the unknown. When scientists detect nickel in a comet from another star system, it's not just another data point for a research paper. It's a powerful affirmation that knowledge itself can transcend impossible boundaries. Think about it. That comet traveled for millions of years across untold light years to reach us, carrying the chemical signature of its distant home. And our curiosity, our relentless drive to understand, met it halfway? We crossed the remaining distance through thought, technology, and observation. In that incredible meeting of matter and mind, of a comet and human consciousness, the universe, for a brief, shining moment, knew itself. It's a concept that can be hard to grasp, but it's at the core of our existence. The flashlight that illuminates a few meters of a dark road at night is a perfect metaphor. It represents the human spirit, casting its light into the vast cosmic abyss. The great astronomer Carl Sagan once said that we are a way for the cosmos to know itself. He was describing this very act, the light of our comprehension sweeping across the darkness of the unknown. Astrophysicist Neil deGrasse Tyson often reminds us that our atoms belong to the universe, and therefore the universe is quite literally within us. So when we study the nickel in a distant comet, we are, in a very real sense, studying our own ancient ancestry. To gaze upon that spectral line is to look into a mirror older than the Earth itself. As that interstellar visitor, that comet, disappears back into the depths from which it came, we aren't left with a sense of emptiness. Instead, we are left with a quiet, profound revelation. We realize that the universe isn't some distant, cold spectacle we merely observe from afar. It is our intimate companion. Its stories are written in every element, every photon of light, and every single beat of our hearts. The discovery of nickel in that wandering chunk of ice and rock is just one more chapter in a cosmic autobiography that includes every single one of us. It teaches us that even the coldest, most remote objects in space carry within them the memory of fire, the very same fire that burns in our sun, the fire that powers our cities, and the fire of curiosity that burns in our thoughts. Someday, perhaps, we will send our own emissaries beyond the edge of our solar system. We'll send probes carrying samples of Earth's matter, messages from humanity and traces of our own technological fire. And perhaps, millions of years from now, another civilization on a distant world will detect in our artifacts the spectral lines of nickel, iron, carbon, and hydrogen. From those simple clues, they might be able to deduce our story. They will learn that we, too, were born from the dust of stars, that we built small lights to imitate the great ones that dotted our night sky, and that, above all, we dared to wonder. In that distant, imagined encounter, separated by an almost unimaginable gulf of time and space, curiosity itself will have bridged the abyss. The universe is vast, almost beyond comprehension, yet it's bound together by simple, elegant truths. Among the most powerful of these truths is this: light reveals. Whether it emanates from a star a billion light-years away from the reflected tail of a comet or from a humble flashlight held in human hands, it is light that transforms the darkness of ignorance into the warmth of understanding. We live in a cosmos that began with a flash and explosion of unimaginable brilliance. Ever since that first moment, every spark we create, every discovery we make, is a continuation of that first primordial illumination. The discovery of nickel in an interstellar comet is a beautiful reminder that even the smallest, faintest gleam of light can connect us to the most ancient and powerful fires in the universe. It reminds us that knowledge is a flame worth tending, and that our curiosity is our greatest and most reliable source of light. Somewhere out there, right now, in the endless black sea between the stars, other comets are gliding silently. Other elements are waiting to be detected. Other incredible stories are just waiting to be told. And as long as we keep our own fires alight, our science, our wonder, and our humility, the universe will never be completely dark to us. Because even in the coldest, darkest depths between the stars, the atoms of nickel shimmer faintly. They recall the time when they burned hot and bright in the heart of a star, and they whisper a timeless secret to anyone who will listen. We were fire once. And so are you. Thank you so much for joining me on this cosmic journey today. If you enjoyed this and want to explore more of the universe's amazing stories, please consider liking this video and subscribing to the channel. It really helps us continue to create content like this. Until next time, keep looking up.